Laser bay, this is where the big laser meets the tiny target. We wear these bunny suits out here. They're to protect the laser, and we wear glasses. That protects our eyes from the laser. The lasers in the building right next to us, or the room right next to us, is the size of a football field. It's huge. The energy in that laser beam is 20 times the amount of electrical energy flowing throughout the entire United States at any one time.
The target is a tiny tube containing the same materials you'd find at the heart of a star.
When the laser hits this target, that creates a shock wave that's so strong that it shreds the material inside that tube. It tears the atoms apart.
Inside the tiny target is Paul Drake's version of a star just before it explodes. The inside of a dying star is made up of layers, like the layers of an onion. The outer layers are the last remnants of the gases that once fueled the star, mostly hydrogen. Deeper, there are layers of calcium, sulfur, carbon, and at its heart, a dense core of molten iron. Drake's tiny target is packed with these same layers. It's like a slice through a star. His aim is to see what happens when a star explodes.
Five, 4, 3, 2, 1.
Here, slowed down millions of times, is what his experiment reveals. The complex patterns of an exploding star shown in astonishing detail. The beautiful and precise motions that scatter the building blocks of life out into space.
That explosion of the star throws the elements that were formed in the star outwards. They go outwards into the galaxy, and some of them gather together and form other stars, solar systems, even planets like the Earth.
These images, captured by our most powerful telescopes, show the remains of these violent events. Vast clouds of star stuff expanding through space, one of the most breathtaking sights in the universe. But there's a puzzle in these pictures. It may be the stuff of life, but these are just clouds. What could turn a cloud into rocks or water? What could turn a cloud into life? We've begun to piece the puzzle together. We've traced the whole process from the death of a star to the creation of new worlds. It has taken the most powerful telescopes and years of patient searching by hundreds of scientists. One of them is Professor Bob Kirshner. They call him the godfather of supernovas.
There's a bright supernova once every 100 years or so in a galaxy. So you're pretty lucky if you get to see one in your own lifetime.
In 1987, the astronomers' dedication finally paid off. For the first time, they actually saw the moment of destruction, a star exploding, a supernova, in a nearby galaxy.
This is supernova 1987A, and we can see all kinds of parts of this exploding star. The heavy elements, the new elements that could make a new planet someday, are in this little dot down in the center. That's the actual new stuff. And then, over tens of thousands of years, that shrapnel from the exploding supernova gets mixed in with the gas in the gas between the stars, and that becomes the stuff which contracts under gravity to become new stars, new solar systems, new planets. When you pick up a rock, you're picking up a piece of the universe that was formed 5 or 7 billion years ago. The silicon that makes up these shiny bits of quartz were manufactured deep in the insides of massive stars and blasted into the gas between the stars. But it's not just the rock. It's everything that you see around you in the Earth. In this countryside of Arizona, you can see the beautiful mountains, which are all formed out of elements that were manufactured a long time ago from generations of stars that blew up 5 or 7 billion years ago.
Over hundreds of thousands of years, countless supernovas spread and mingle. And this is what they become: immense clouds made from ancient hydrogen gas mixed with the remains of long-dead stars. It's a stellar nursery, a place where new stars and new planets are born.
This is the Eagle Nebula, a vast cloud of debris, the remains of an ancient explosion. At its heart, new stars and worlds are being created. These interstellar clouds are immense. Each one of these bright dots is a star, many of them much bigger than our own sun. It was in a place like this that our solar system was born. All the ingredients needed for the creation of everything are in here. It just takes a little time for them to come together.
It's a dance that lasts millions of years. It starts when the gas and dust form microscopic clumps, and it ends with new worlds. As the clumps get bigger, they start to stick together too. They form clumps of clumps, always bigger, always heavier, all swirling around each other.